coordinate systems. Physical quantities in electromagnetic fields are functions of space and time. Spatial variations of physical quantities are defined by points in space. Points and vectors can be represented in curvilinear coordinate systems. Coordinate systems may be orthogonal and non-orthogonal coordinate systems. Non-orthogonal systems are no practical use. Orthogonal system is one in which the coordinates are visually perpendicular to each other. Coordinate systems are Cartesian coordinate systems, cylindrical coordinate systems and spherical coordinate systems. Cartesian coordinate system is the simple coordinate system. First we will see Cartesian coordinate system. In Cartesian coordinate system, we are choosing three coordinate axes, say x, y, z. This is x axis. This is y axis and this is z axis. We are having three axes. They are mutually perpendicular to each other. And we are choosing right-handed coordinate system. Rotation of positive x axis towards positive y axis will give the positive z axis. And unit vectors are represented by this. This is the unit vector along x axis ax, and this is the unit vector along y axis, and this is the unit vector along z axis. We can represent the point in coordinate system by three coordinates. Say for example, I want to represent P. P is equal to 1, 2, 3. It is represented like this. Z axis. X is equal to 1. So along the x axis we are taking 1 unit, and along y axis we are taking 2 units, and along z axis we are taking 3 units. Point P is the intersection of three planes. X is equal to 1, y is equal to 2, z is equal to 3. This is x is equal to 1 plane. This is x is equal to one plane. Next, y is equal to second plane. Is y is equal to 2 plane. Next, we have to take z is equal to 3. And this is the intersection of 3 planes. So this is point P. This is point P. 1 dash 2 dash 3. Now we will see what is the dot products of unit vectors. Dot products of unit vectors. Ax dot Ax. The angle between same axis is 0. Cos 0 is 1. Ay dot Ay is equal to 1. Az dot Az is equal to 1. Next, Ax dot Ay. The angle between two adjacent axes is 90 degrees. Cos 90 is 0. Ay dot Az is equal to 0. Az dot Ax is equal to 0. Next, cross products. Ax cross Ay is equal to Az. Ay cross Az is equal to Ax. And Az cross Ax is equal to Ay. Next, range of parameters. X may change from minus infinity to plus infinity. So, minus infinity is less than or equal to x, less than or equal to plus infinity. Similarly, y coordinate, it may vary minus infinity to plus infinity. So, minus infinity less than or equal to y, less than or equal to plus infinity. And similarly, z coordinate will vary from minus infinity to plus infinity. Next we will consider differential lines. For this one, we will consider 2 points. First point is P with coordinates of x, y, z, and the other point is with small increments. This is A, this is B, and this is C, this is D. And these points are E, F, G, H. Now I want to find the distance between A to G. Distance between A, G. So the distance between AB can be written as AB plus BC plus C. AB is along y-axis, so this is the elemental length, so this is dy, ay plus BC is along z-axis, is the elemental length. So dz az plus cg. Cg is along x-axis. So ax dx ax. And rewriting this one, ag is equal to dx ax plus dy ay plus dz az. So this is the elemental distance or elemental length. Next we will see differential surfaces. Differential surfaces. Here we are considering 3 surfaces. First surface is AB, CD. A, B, C, D. And differential surface one is equal to, it is along y-axis, so dy, and this one is along z-axis, dz, and is the unit vector in this direction, so Ax. This is differential surface 1. Next we will consider differential surface VFGC. BC, G, F. Differential surface 2 is equal to, this is along x-axis, so elemental distance along x-axis dx, and this one is along z-axis dz, and the unit vector is in this direction, so this is along y-axis, so A. Next one is differential surface, third one. This one we will consider. B, C, G, H. Unit vector is in this direction, and DC is along y-axis and elemental distance. So dy, differential surface 3, dy, and this surface is along x-axis and elemental distance dx, and this unit vector is along z-axis. So yes. Next, differential volume. Differential volume is equal to the distance multiplied by this distance plus this distance is nothing but dV is equal to dx dy dz. It is nothing but volume of the cube. Next we will consider cylindrical coordinate systems. Cylindrical coordinate system is easy for cylindrical symmetrical problems, that is for cables and machine rotors. Any point P, rho phi z is represented by the intersection of three mutually orthogonal surfaces. So the surfaces being circular cylinder of radius rho is equal to constant, A plane phi is equal to constant and a plane z is equal to constant. P rho phi z. Rho is the radius of circular cylinder. Phi is the angle from x-axis. Z is height of the z-axis. This is x-axis and this is y-axis and this is z-axis. They are mutually perpendicular to each other, and rho is the radius of the circular cylinder. This is rho, this is the angle phi. Three surfaces. One is circular cylinder. Next one is, this is the phi. This one. Next one is z. This is the length along the z-axis. This is one more plane. Intersection of these three planes will give you point P. And the unit vectors are A rho, A phi, Az, and this is rho is arrow. Arrow is along direction of rho. It is like this. And A phi is in the increased direction of phi. This is A phi and Az is along z direction. Next we will see the dot products. Arrow dot arrow. The angle between the same axis is 0. R0 is 1. And A phi dot A5 is equal to 1 and AZ dot AZ is equal to 1. Next one is the dot product between two adjacent axes. A row dot A5. The angle between two adjacent axes is 90 degrees, cos 90, 0. And A5 dot AZ is equal to 0. AZ dot A row is equal to 0. This is the dot products and the cross product. A row cross A5 is equal to AZ. A5 cross AZ is equal to A row. And AZ cross A row is equal to A5. We have seen what is cross product and what is dot product in the first chapter. We will consider one point P is equal to, in terms of A row plus A5 plus AZ is the point, and we are incrementing this one by elemental values, and we are finding out the differential length, the differential surfaces and the differential volumes. This is phi, angle made by the x-axis is phi. This is increment in the angle d phi. And the distance is rho. We are projecting to the y-z plane. This is the radius rho. This radius rho is incremented by d rho. So this is same length and the angle is d phi. Angle is d phi and this one is d rho. So this is point P. This is one surface you are getting. After incrementing each coordinate, you are getting a point Q. This is point Q and this is P. And this is d rho and this is dz, incremental distance along z axis, and this is d phi and this is also d phi. So when this is d phi, this is the d rho, this length is and similarly unit directions are, so this is along z axis, so this is AZ and this is along radius rho, so this is unit vector is in this direction and this is A phi, this is the unit vectors A rho, A phi, AZ. This is the one surface. The other surface is this one. We are getting one more surface, and the third surface is this one. This is point P. By incrementing each coordinate by a small value, you are getting Q point. Next we will see all the differential length, differential surface, differential volume. Before going to that one, we will see range of coordinates. Range of parameters or coordinates. This rho is the radius of circular cylinder. It is starting from origin and it may go up to infinity. So 0 less than or equal to rho less than or equal to infinity. And next one is phi. Phi can take maximum value of 2 pi. So 0 less than or equal to phi less than or equal to 2 pi. And z can take maximum value in this direction, that is minus infinity, in this direction plus infinity. So minus infinity less than or equal to z less than or equal to plus infinity. Next we will see differential lines. Differential lines. Differential length from P to Q. So what is the distance from P to Q? The distance is this one. This is d rho. d rho, unit vector is a rho plus this one. This one is, what is the value of this one? The angle is d phi. This length is rho. This is rho d phi. So rho d phi, rho d phi. And what is the vector in this direction? Unit vector a phi. What is the third length? This one. This length is along z axis. So dz. Unit vector is az. This is the differential length from P to Q. Length from P to Q. Next we will see differential surfaces. Differential surfaces. What is the first surface? This is the first surface. Surface 1. Surface 1. What is this? What is the length? D rho. Surface 1. Differential surface 1. This is d rho. This length is d rho. And what is the length? This is, what the angle is d phi, and this one is rho into d phi. So this length into this length, d rho into rho d phi, rho d phi. And what is the unit vector? Normal to this one, az. Next, differential surface 2. Differential surface 2. This is the differential surface 2. This is rho d phi. This length is rho d phi, and this height is dz. What is the unit vector normal to the surface? A rho. And the third one is differential surface 3. Differential surface 3 is equal. This is the differential surface 3. So what is this length? D rho. What is the height of this one? Area dz. What is the vector normal to the surface? A phi. So this is the 3 differential surfaces. Next, differential volume. Differential volume of this tube. You multiply the 3 distances. dV is equal. What are the 3 distances? One distance is rho d rho. Next one is d phi dz. So this is the differential volume of the